Hello, assalamu alaikum students. Welcome to the Cambridge Companion, and today we will do chemistry A level, AS and A level paper uh, 2 variant 229701. Uh, so today we will solve this paper. Alright, so question number 1 here is complete table 1.1 using the relevant information from the periodic table. Uh, the question is there is given the nucleon number of the magnesium and aluminum ion. So magnesium nucleon number is 24. So we should complete this table. So what is the proton number of the magnesium? What is the atomic number of the magnesium? As you've seen from the periodic table, you will find out there are 12 number of protons. Okay, because atomic number of the magnesium is 12. Okay, to write just write 12. Just write 12. All right, like this. And how many number of electrons? Please be careful to fill out this. Magnesium has also have a 10 12 electrons, but here is show the plus 2, a positive 2, so it means magnesium loses 2 valence electrons. It means magnesium left with the 10 electrons only. So write 10 here, 10. All right. And the other part of this question is aluminum ion. Okay, nuclear number is 27, and if you find out from the periodic table the number of proton present in the aluminum is 13, so write 13. So and it loses the 3 valence electrons. It has a positive 3 sign here, so it means it loses 3 electrons. So 13 minus 3 which is 10. Right, so here uh, move to the next part of the question number 1, which is state and explain the difference in the ionic radius of aluminum ion and magnesium ion. So aluminum ion is a plus 3 charge and magnesium ion is positive 2 charge, which means aluminum ion is smaller. All right, sorry, we will write write 5 here. So it means aluminum ion, just zoom it out and write the text here. Aluminum ion is smaller. Aluminum just make the ion like this. Aluminum is smaller than magnesium ion All right. The first point is that ammonium ion is uh, smaller than the magnesium ion. So greater, right? Greater nucleus attraction, greater nuclear attraction for remaining electrons. So greater, right? Greater nuclear attraction for the remaining electrons. Also, we have same shielding effect, and greater nuclear charge. Here is some spelling is wrong here. Greater nuclear charge. So we are finished this part B. So move to the part C. All right. This said to draw a label diagram to show the structure and bonding in the sodium. So just draw it. All right. So we have not a um, you know just draw the structure of the bonding in the sodium. All right. Just draw it, and we are here drawing bonding in the sodium. Okay. Actually, make draw it perfectly so we don't have a proper circular the object. So I'm just drawing it for understanding purpose only. Right. I hope you can understand this. Draw with the proper arrangement. Right. Just draw it. Oh my God. So so just uh, uh, drawing for here. We are drawing for bonding in the sodium. And here we don't forget to draw the sea of electrons, alright? Don't forget that. Sea of electrons. Oh my god, I think it's just draw it. And here just draw sea of electrons. This is the sea of the electrons, which is negatively charged between the positive charge, right? Okay, move to the next part. Uh, the next part, part D, said figure 1.1 shows the variation, the melting point of the sum. Uh, uh, you know, show the variation, melting point of period of the elements in the third. In their period 3 elements in their standard states of the room temperature and pressure. Here you can see the melting point is increasing from sodium onwards, and it is constant between these. Alright, and it increases increasingly, and it stops the silicon, which is showing the higher melting point. Uh, Part 1 from the question number 1, part D. Part 1 is explain why silicon is a high melting point. Uh, it means silicon, it's a high melting point. It means silicon means Si, you know, Si has a giant covalent structure. Si has a giant covalent structure. Okay. Therefore, so there is spelling mistake. The sum of, right? Therefore, high energy is needed to break the bonds. All right. So move to the next part of the question. So the next part is asking for complete figure 1.1 to show the variation in the melting point from phosphorus to chlorine. Alright, we all have already seen uh, the silicon is a high melting point, but from the silicon, for because phosphorus has a simple molecular weak van der Waals forces, so melting point will decrease, right? Uh, just draw. Sulfur is slightly high than the phosphorus, and like this down this chlorine. So here we have done. So move to another part E2 period. Uh, Three elements react with an excess of oxygen at room temperature. So complete figure 1.2, here is table 1.2. Uh, there is sodium and sulfur. So state of the oxide at the room temperature and pressure. All right. So what is the sodium oxide of the sodium room temperature and pressure? So of course it is solid. Just remove it and just you know try it with the text here. It's approximate pH. Here, another table we have. So I think it's not an acidic, so this pH is higher. So with between 10, alright, 10 to 14. Alright. But what about sulfur? Sulfur is just here solid? No. Sulfur here is oxide of the sulfur, which is sulfur dioxide or trioxide, which are gases. Alright. So it present the gas at room temperature. And what is the pH? Because sulfur is acidic, so its pH is low. So between here is 0 to 14. Right. So move to the another part 2, the part E. The solution made in the column 3 of the table of 1.2 are mixed together. It means this is the mixed together. Name the type of the reaction. Of course, it's acid-base reaction. All right. This is the sulfur oxide is acidic, and this is the base. So acid-base reaction. It is acid-base reaction. All right. All right. We have another part 3. We have just asking write equation to describe the reaction between the phosphor oxide with react with water. So we should write the equation and balance it. It's the P4 O10 plus water Just here with correction of I think the two. Mm, so we have phosphor oxide, which is reacts with water, so which is gives a phosphoric acid. H3 PO4. I think this would be likely a product. All right, so but here the equation is not balanced. Think there is two, yeah, there is two hydrogen. So if we you must rebalance, I think 6H2O here and 4. All right, I think so. There, the left hand side the reactants 4 phosphorus, the right hand side the products with the 4 oxygens 10. So 10 plus 6, there are 16 oxygens. So 4 4s are 16 oxygen, it is balanced. 6 2s are 12 hydrogens, and this 4 3s are 12 hydrogens. So it is balanced now. All right. So move to the another part F, aluminum oxide, then amphoteric. Explain what is mean by the amphoteric. So uh, reacts. It's just right. Answer is uh, it shows both acidic and basic behavior. Right. Amphoteric. So it shows both acidic and basic behavior. Move to the next part. Here is shown on the right an equation to describe the reaction that occurs when the aluminum hydroxide reacts with sodium hydroxide. So here we do a simple balance. It's not a difficult task. Sodium hydroxide. So what we get here, the product we get NaL. What is it combined? Right, L with the small letter. So here we got the answer. Move to the question number 2. They're asking complete the reaction pathway diagram in the figure 2.1 for the reaction to label the diagram to show the enthalpy change of then the activation energy. Okay, that's two separate sample of the sodium carbonate and NaHCO3 react with that Cl to produce the same product as shown. All right, shown. This is the reaction 1. Here is enthalpy change, and this is the reaction 2. The enthalpy change with the positive. Here is endothermic. All right. Complete the reaction pathway diagram for the reaction 2. Is it endothermic? So they are asking to complete, then label the diagram, which is delta H2 and the activation EA of the energy. So here we have reactants. All right. It should be like this. Or no, it's not. It should be like this. I think it's something missing here. Straw. Something like this. And this is EA, right? And here is the delta H. Because be careful, the reaction is the endothermic. So write the products here. This N. Just we'll draw light a little bit like this. Just write the text here. Oh my god, it's no way. I should draw this again. Just remove one time more, and you know there's computerized, so let's draw it again. No, it's manually it is easy to draw, but here in computer sometimes you feel a difficulty here the computer. Right, just sketch it. Here you will draw an activation energy EA. Here is delta H. Delta H. And just write the text. Let's write just write the product here with the reaction 2, which is NaCl plus H2O H H2O and plus CO2 plus CO2. Here we complete it. So move to the next part of the question 2, part B. Um, value of the delta H1 is determined by the experiment using the following method. Uh, 50 centimeter cube of the 2 mole per dm cube of the HCl is added to the polystyrene cup. The initial temperature of the acid is recorded to 19.6 degrees Celsius and 0.04 moles of the Na2CO3 is added to the mixture stirred. All the solid Na2CO3 disappears. The colorless solution is produced. The maximum temperature recorded during the reaction is 26.2 degrees Celsius. So, they describe one other observation that shows the reaction is completed. All right. So it means no more fizzing. So it shows that stop there, no more fizzing. All right, no more fizzing. Okay, move to the next part. Calculate um, the value of the H1 the kg mole. Assume the specific heat capacity of the reaction mixture is the same as for the water. So water is a 4.18, I think, and there is no heat is lost to the surrounding. So uh, we must write the formula here. The formula Q is equals to MC MC delta H. Okay, which is delta H. Right? So Q is equals to MC delta H. So this is the M is the speed in volume, which is 50. Multiply by the specific heat of the water, which is 4.18, and multiply by change in the temperature. What is the change in the temperature? Just minus initial temperature was. So what we get here is equals to uh, it's just right. It's just right. Whatever we have 50 multiplied by 4.18 into 26.2 minus 19.6. It's got 1379.4. But now you see that there is 0.04 mole of the Na2. So we are calculating those. Okay. So just divided by 0.04, all right. 1379.4 divided by 0.0400. So here we get equals to what we get. Uh, 1379.4 divided by 0.0400. 34485. 34485. So here you can write 30 um, 30 is equals to 34.5 kJ, right? Kilojoules. But we here write with their temperature is increasing since the temperature was 19.6 and the temperature raised. So temperature raises 26% exothermic, all right? So minus 34.5. Here we have answer. All right. Now move move to the next part, the part 3. Thermal decomposition occur when NaHCO3 is heated. A reaction is shown, which produces Na2CO3 plus water plus carbon dioxide. So calculate the enthalpy change for the reaction 3. Alright, HR using the data table in 2.1 and the value of the H1 is calculated. Alright, if we are unable to calculate the value of the H1, so assume the enthalpy changes, which is not a correct value. Have find out. Alright, just do it. Which is there are 2 moles of the NaH3. Alright, 2 moles of the NaH3 and 2 moles of the NaHCO3, but there is a reaction for there is 1 mole of the NaHCO3. So 2 multiplied by H1. Alright, sorry, 2 multiplied by H2. You can see. Alright, which means 2 multiplied by what is the value of H2, which is plus 27.2. Alright, this means 2 multiplied by 27.2. 22 minus what's the value of the H1? It's 34 point, which is a minus 34.5. We get, if we just here we write 12 multiplied by 27.2 minus 34.5. We have got 88.9. So 88 point, sorry, so which is endothermic, 88.9 endothermic, right, plus 88.9. So we have last part of the which means they are asking Z is a salt that contains a period 4 of the element from the group 2. It means it confirms that it Z is a salt contains with the period 4 in the group 2 element. So right. So when Z is heated, a brown gas forms. So we have another. So it's a salt of the group. It confirms that group 2. So salt is likely to be calcium nitrate. All right, calcium. So uh, so when is heated, so what we will get, we there's a metal nitrate of the group 2, so it must form a calcium oxide, also metal oxide, plus it gives a brown form of the NO2, which means nitrogen dioxide, and the oxygens. All right, but we must check the balance. So calcium is balanced, oxygen is not balanced. All right, so we must add the 2 here, and sorry, I think it's 2 and 2 and 0, 4, 5, 6, and there is 5. So just 5 to 4, 1 over 2 over 2. So here is completed. So this is for question number 2 we have done. In the next video we will do inshallah question number 3 and other questions. So uh, Allah Hafiz for now, and we will meet in the next video, and please like and subscribe my channel. Thank you very much.